Today we're going to talk about derivatives. What is a derivative? The derivative is the average rate of change between any 2 points or the instantaneous rate of change between two very near points. And here is the average rate of change formula using the difference quotient, where h is going to be 0.001 and x is 3. And we plug this in and we find out that our derivative is 18 at 3, which is pretty steep. Can we determine the formula for a derivative? So let's look at the function. What do we know? We know that the coefficient is 3, excuse me, and the derivative of x is 3 at x is 3 is 18. So we can surmise anything about this. Well, 18 divided by 3 is 6, so we know that x is equal to 3, then 3 times 2 is equal to 6, so 6 times 3 is 18. So that will help us. So with that, can we derive the function, the derivative equation? And it is 3, which is the coefficient of x squared, times the exponent on the x value, which is 2, times x. So we have 3 times 2x, or 6x, for our derivative function, or equation. What is the slope at x is 6. 6 times 6 is 36. So let's summarize what we think we know thus far. We know that when you have a constant function, then the derivative of that constant function is equal to 0. So the slope of a horizontal line is equal to 0. When we have a linear function, the slope is negative, then the derivative function is going to be the coefficient of the x. 3, remember, represents a horizontal line, so the derivative of 3 is 0. When we have k times x, then f prime is equal to k, that constant. So now if we have y is equal to f of x is equal to k times x squared, so we have 3x squared for our parabola, then the derivative of that is going to be 6x. So the derivative of a quadratic is a linear, the derivative of a cubic function is a quadratic function. So here is the derivative formula. This is the sum and difference formula. You take the derivative of each one of the terms and then add or subtract depending on your function. And here is the formula. The derivative with respect to x of x to the n power is equal to n times x to the n minus 1. Now let's look at a few examples. This is number 4 in your book. 12 times x raised to the 12 minus 1 power is 11. If you have a denominator with the exponent, then you have to change that so that it is in the correct form. So now we have x to the negative 4 power. We can use that to find the derivative. Either one of these is appropriate or will be accepted. If we have y is equal to the square root of x, we have to write that as an exponent. So x raised to the 1/2 power, and then it's 1/2 times x raised to the negative 1/2, because 1/2 minus 1 is negative 1/2. Number 28, we have 3 parts, so this is a polynomial function. So we have x squared, or t squared here, 12 divided by the square root of t, and 1 divided by t squared. So we rewrite it in the correct form, and then you can take the derivative. Q is equal to tons of material of waste at a waste site as a function of the number of years since 2000. So Q of t, which is equal to f of t, is equal to 3t squared plus 100. We want to find the value at that point, so we plug in 10. 3 times 10 squared plus 100 equals 400 tons, and now we take the derivative. 2 times 3 is 6, 2 minus 1 is 1, So we have the derivative function is 6t. So the derivative when t is 10 is equal to 60. So that means the waste site is increasing by 60 tons per year. And to find the relative rate, you take f prime divided by f. So f prime was 60. The function was evaluated at 10 was 400, and divide that and you get 0.15, which is 15% per year. And here is another one, marginal cost. If this is the cost, then the marginal cost is 2 times 2, which is 4q. So the marginal cost at 25 would be 4 times 25, or 100. So my cost is increasing $100 per unit.